Okay, so the first thing you're going to do is you're going to get some data. You're going to get a paragraph that's going to talk about a biologist doing some kind of test. And there's going to be some data in a table. So you're going to have to be able to read a table. And the first thing it's going to do is ask you about controlled variables.
Control variables is the thing that stay the same in the whole experiment.
The variables are the things that you're going to keep constant, all right? The constants. So you have to try to figure out what those are in the experiment. And they don't really give you a lot of detail of the experiment, or I don't because I wrote it. So I didn't give you a lot of detail about the experiment, but you have to be able to say, well, here it is. This is what I have. What variables are controlled? Which of the following? Oh, I'm about to read the question. I hate when I do that. The next thing that I ask you to do is define the dependent and independent variable.
Wasn't that in our study guide?
All this is out of your study guide. Yes, I've given you this 3 or 4 different ways. I've given you 3 different activities. I explained it in class. I sent home videos. I asked you to do it for homework. I asked you to ask questions on Monday. Some of you did, some of you didn't. I wrote it in the study guide. I explained it again when we went over it yesterday. What do you want me to do, guys? This is it. If you're not going to do it, then you're not going to do it. All right. I've been here. I was here after school yesterday. No one showed up for tutoring. I was here at 7 o'clock every morning this week. No one showed up for tutoring. I was here at lunch. No one asked to come here. I think one person showed up and said I wasn't here, but I was. So I don't know how that happened. So at this point, it is what it is. Dependent or independent variables, you have to be able to identify them. I'm literally going through the test and telling you what you need to be able to do. You have to be able to tell what a good hypothesis is. You can be given some choices. So what determines a good hypothesis? And of course, it's multiple choice, so you're going to choose the best one of the 4, right? So what's a good hypothesis?
You say if then, right?
Okay, so you want to kind of try to stick to the if-then statement, although there's not always an if-then statement, but you definitely kind of want to see it an if-then statement if it's possible. What else makes it a good hypothesis? What are the qualities of a good hypothesis? Yeah.
Relating to the experiment.
It has to be relating to the experiment. Excellent. It has to actually be related to the experiment. Whatever you read, if you read that, if you're asking an if-then statement about the color of the sky when you're talking about measuring mass, then it's not a good hypothesis. The hypothesis has to try to answer the question, right? Has to try to answer the question. What else? Yeah.
Testable, like it can be tested.
That's right. It has to be tested. You know, you have to be able to test it. It's not a good hypothesis if you can't test it. Then it's not science. Okay, so that's pretty much for a good hypothesis. You have to try to, you're going to be given these things. There's going to be 4 of them. You have to choose the best one, the best hypothesis considering the experiment that you're given. All right. So then you're going to get a graph. It's a graphic analysis. You're going to be given a graph, and you're going to have to be able to say, what does this graph mean? So you're interpreting the graph. Does that make sense to everybody?
Yeah.
Yeah, question? I don't want to deal with personal issues right now. I just want to get through this, if you don't mind. The next thing is, can you predict? Use the graph to predict. So you have to interpret what the graph means, and then use the graph to predict. All right? If you can do that, then you're in pretty good shape. Then you have to be able to tell what is a control group, a positive and negative control. And you can watch the previous videos that I uploaded if you're confused about that. We did it in class, we talked about it, defined it several times, about 5 different examples. That's all I can do. I can't do much more than that. So it's a control group. You have to be able to identify a control group, and if it is one, is it positive or negative, that kind of thing. Then you have to consider a conclusion, a logical conclusion. Can you come up with a logical conclusion? All right. And then once you have a conclusion, can you generalize it? How far can you take it? Right? How far do you generalize the particular result of the experiment? So if I throw a ball up in the air and it comes down, I throw it 100 times, I do all kinds of tests. Every time I come to the conclusion, every time something goes up, it comes down. Can I say that about everything that happens on Earth?
No.
No.
Yeah, I think I can say every time I throw something up, it's going to come down, anywhere on Earth, whether it's here in India or anywhere on Earth. On the surface of the planet, if I throw something up, it's coming down. But can I generalize that about everywhere in the universe? Can I do it in space? Will that happen in space? No, it won't. So it's how far do you generalize? And you'll have to figure that out. And then the last question has to do with the TB discussion. So you better be familiar with the whole TB experiment, and it has to do with tuberculosis and whether you know how important that disease is to the history of humanity or whatever. So that's it for the multiple choice. Let's take questions. The one class that took it today, they got something like 790s, 780s, 760s, a 150, 140, and 130. I hope you're not the 30, and I hope you're one of the 90s. I hope everybody does better than that, but that's what we have so far. But you have an extended response section worth as well. And remember that the extended response is worth 2 times the multiple choice. So what are the 3 extended response questions? First, know the scientific method. Know the method and be able to describe each step. If you can't do that, you're in trouble. And so the method is going to be up there, but that's not all the details. I'm going to ask you to go ahead and include, of course, scientific design. So you have to design the experiment as being part of it. So you have to talk about things like control groups, positive and negative, independent, dependent variable, collecting data, as part of your data discussion, not just data, right? No, you have to describe what you need to do to make it a scientific experiment. You can go if you want. I'm gonna go ahead and finish the essays, telling you what's on the essay. It's time to go, so you can go if you want, but do it quietly so you don't interrupt the rest of us. That's the first thing. Second thing is there's going to be a question on agriculture and its negative impact on ecology. On the ecosystem. And your body, right? And your body. Don't forget, the clue here is going to be antibiotics as far as human health in our present agricultural system. And lastly, there's going to be a graph, the same graph that you had earlier, and this time you're going to draw the best fit curve.
Curve? What's a curve?
Curve. Oh, why isn't it showing up? Oh my goodness, all this time nobody said anything. It's not showing up, you're not.
I didn't know it was gonna be up there.
Oh well. I certainly usually am here by 7, but sometimes something happens. I can't promise. Best fit curve.
How would I even get in the building?
Well, I would show up at 7:30. I wouldn't show up at 7 because you can't get in the building until 7:30. Why do you want to come at 7 instead of 7:30?
No, I thought that's what you said. I thought that you said come at 7.
No, I said I come at 7.
Oh,
I'm here at 7. If it's an absolute emergency, I can meet you and bring you up, but usually that's not something that they like us doing. What is it that you want to do tomorrow morning? What
just
is,
to help me scan the stuff because I did my work.
I see.
Said that
Is